Hi everyone. In this video I'm going to show you how to set up and run a hypothesis test for a single proportion in StatCrunch. So let's say we've got a deck of cards and you draw 10 cards from the deck with replacement and 6 of them turn out to be clubs. And you want to test the hypothesis that 40% of the cards in the deck are clubs. So first, the thing you would do is you would set up a model for this hypothesis that you made. So since you made a hypothesis that 40% of the cards in the deck are clubs, I'm going to make up a model. So for 40%, there's lots of ways you could build this model. I'm going to make my clubs. I'm going to make, just up to there, 4 out of 10 clubs. And then I'm going to make the rest not clubs. So 6, 7, 8, 9, 10. So this is my model. My hypothesis was that 40% of the cards in the deck are clubs. And this is what my model is saying. 4 out of the 10, or 40%, are clubs. So the next thing I need to do is simulate replicating my experiment, my study, my sample. In this case, my sample was a sample of 10 cards drawn with replacement. So I'm going to go to Data, and then Sample. I'm going to sample from my model. I'm going to sample 10 at a time, because that was the size of my sample. In this case, I'm going to do 10,000 samples. I'm going to sample with replacement. I'm going to compute a statistic for each one. I'm going to build this up. I'm going to use my sum, the sum from my sample, and I'm going to set this equal to clubs. So it's going to count up the number of clubs in each sample here. So hit OK. And I'm going to name this. I'm going to call this number of clubs in hand. So now I've just generated 10,000 sets of 10 cards and counted the number of clubs in each of them. And now what I need to do is compare my observed statistic to the sampling distribution that I've generated here. So there's several ways to do this. I'm going to make a dot plot. A dot plot is going to help me set this up. So I'm going to make a dot plot of the number of clubs. And I'm going to add a divider for percents here. So I compute that. I'm going to make it nice and big. So my observed statistic was 60%. So all of these in purple are going to be what I observed, or something more extreme. And now the center of my sampling distribution is 40%. My observed statistic was 60%. The 6 is 2 more than 4, so I'm also going to look at 2 less than 4. So at 2 and fewer in all of these. And now I can look at the percentages that are up here. I see that if the deck had 40% clubs, then if I add the 16.6 and the 17.2, I get the 33.8. Then there is a 33.8% probability of getting 6 or more or 2 or fewer. Another way to say this is that my observed statistics is among the 33.8% most surprising statistics if 40% was my parameter. So in this case, I would not reject the hypothesis that the deck could be 40% clubs.